Okay. We set? All right, let's check our answers to that review packet. Number 1 is 4. Number 2 is 1. Number 3 is 1. Number 4 is 1. Number 5 is 1. Number 6 is 3. 7 is 1. 8 is 3. 9 is 1. 10 is 3. 11 is 1. 12 is 1. 13 is 4. 14 is 4. 15 is 2. 16 is 1. 17 is 4. 18 is 3. 19 is 4. 20 is 2. 21 is 4. 22 is 3. 23 is 1. 24 is 2. 25 is 2. 26 is 2. 27 is 1. 28 is 4. 29 is 2. 30 is 3. 31 is 1. 32 is 2. 33 is 2. 34 is 2. 35 is 4. 36 is 2. 37 is 1. 38 is 4. 39 is 1. 40 is 2. 41 is 3. 42 is 3. 43 is 1. 44 is 2. 45 is 2. 46 is 3. 47 is 3. 48 is 2. 49 is 3. 50 is 3. 51 is 3. 52 is 2. 53 is 4. 54 is 3. 55 is 4. 56 is 1. 57 is 4. 58 is 3. 59 is 4. 60 is 4. 61 is 2. 62 is 2. 63 is 4. 64 is 2. 65 is 4. 66 is 3. 67 is 3. 68 is 1. 69 is 2. And 70 is 2. All right, the way I'd like to go through this is page by page. So that way we're not flipping back and forth, back and forth, back and forth, back and forth, okay? So let's start on the first page of that packet. That's questions 1 to 3. Would you like to go over any of those 3 questions, 1 through 3? Yes. Yep. All right, it says an object's velocity changes from 25 meters per second to 15 meters per second in 2.0 seconds. What is the acceleration? So I know my VI is 25 meters per second. The VF is 15 meters per second. The T is 2.0 seconds. I'm looking for A. The best equation on your reference table is A is change in V over T, which is the same thing as VF minus VI over T. So that's 15 meters per second minus 25 meters per second over 2 seconds. That's the same thing as negative 10 meters per second over 2 seconds. So the actual acceleration is negative 5.0 meter per second squared. Since I want the magnitude of it, I dropped the sign, leaving me with answer 1. Anything else through question 3? All right, next 2 pages, which are facing each other. So that gets us through question 11. Anything through question 11 that you would like to ask? Sydney? Yes. Number 6 is asking you for the displacement from 2.0 seconds to 4.0 seconds. So the way I'm going to do this from this graph, which is velocity time, is I'm going to get my givens from the graph. So I can see on this graph that my VI would be the velocity at 2 seconds. So if I go up on the graph and over, my VI is 20 meters per second. At 4 seconds here, that would be my VF, which is 40 meters per second, and I'm looking for the displacement. The equation I'm going to use is V bar is D over T, so D is V bar times T. Now, I don't have V bar yet, but the V bar is the average of those 2 numbers. What's the average of 20 and 40? It's 30. So I'm going to take 30 meters per second and multiply by the length of time between 2 and 4 seconds, which is 2 seconds, which gives me a displacement. 30 times 2 is 60 meters. Remember how you get a V-bar? It's if you have 2 velocities, you add them up and divide by 2, just like you would do with 2 test grades. You'd add them up and divide by 2. You don't want me subtracting your test grades and dividing by 2 to come up with your average test grade in this class, do you? If that's what you do on tomorrow's test, I'm happy to go back and change your quarter average to start subtracting all your test grades and dividing by the number of test grades. I'm cool with that. That's the way you want to find an average. I'm cool with that. You're going to see your quarter grade is going to go into the toilet. You don't want me to do that. Remember how you find averages. You add up values and divide by the number of them. And that's what you have here. All right. Anything else you want to ask through question 11? Khalees? Number 8. Okay. And number 8 is based on some of the information that we see down here on the bottom of the second page. In a drill during a basketball practice, a player is running the length of a 30-meter court and back. The player does that 3 times in 60 seconds. So what is the average speed? All right. So I'm looking for V-bar. I need to know how much distance the player travels and in what amount of time. Based upon what I see here at the top of the page, I know the time is 60 seconds. Now, in one drill, the player goes out and back. That's 60 meters, 30 meters out, 30 meters back. And we are told that they do that 3 times. So 60 times 3 is 180 meters. So to get my V-bar, I'm going to take the distance and divide by the time. That's 180 meters in 60 seconds, which gives me 3.0 meters per second. Choice number 3. Anything else through question 11? Yes. Number 7. All right. Number 7 says that we have an object accelerating uniformly from 3.0 meters per second in the east to 8.0 meters per second east in 2.0 seconds. What is the acceleration? All right. So if I list my givens, my VI would be positive 3.0 meters per second. My VF would be positive 8.0 meters per second. The T is 2.0 seconds. I'm looking for A. To get that, I'm going to use A is change in V over T, or VF minus VI over T. So that means I have positive 8.0 meters per second minus positive 3.0 meters per second, all over 2.0 seconds. So 8 minus 3 is 5. So I get a change of positive 5.0 meters per second, which I have to divide by 2 seconds. 5 divided by 2 is 2.5, choice 1. Anything else through 11? Number 11. Number 11 is referring to this graph right here. I want to know the acceleration at 5 seconds. Right here is 5 seconds. Acceleration from a graph of velocity time is the slope. So if I were to look at the slope of the line segment right there, that slope is 0 because it's a horizontal line, which means at that moment in time, there's no acceleration, choice 1. Anything else through 11? All right, next 2 pages then, through question 20. Through question 20. Anything there through question 20? 1. 13. All right, number 13 is showing you a boat going across a river at 2.0 meters per second, but the river is moving downstream at 1.5 meters per second, and I want to know what's the resultant. We talked about doing resultant displacements in Unit 2. You can also do this with velocities or any vector. To figure out what the resultant is, you add these vectors head to tail. So I'm going to do that. 2.0 meters per second down, and then the river pushes the boat this way at 1.5 meters per second. The resulting velocity is that arrow drawn head to tail. How do you get the hypotenuse of that triangle? Pythag. So let's go ahead and do that. 2 squared plus 1.5 squared, then take the square root of that, and that's going to give you 2.5 meters per second, choice 4. And of course, it is pointing down and right. The boat is going across. The river goes to the right. So I need something that goes across and right. The only one that goes across and right is either this one or this one. The boat can't go straight across. But then we didn't necessarily even have to calculate this because I think you all know that the hypotenuse of a right triangle is the biggest side of the triangle. It can't be the same side, same length as one of the legs. So 2 would have to be out. Anything else through question 20? Khalees? Number 12. A group of bike riders takes a 4-hour trip. During the first 3 hours, they travel 50 kilometers. In the last hour, only 10 kilometers. What's the average speed? So what I can tell from this is that the total distance traveled is 60 kilometers, and the total time of the trip is 4.0 hours. I'm looking for the average speed, which is V bar. To get the average speed, we take the total distance and divide by the time. So that's 60 kilometers in 4.0 hours. 60 divided by 4 is 15, choice number 1. Anything else through 20? Yep, Khalees, another one. 16. All right, 16 is referring to this graph of speed versus time, and I want to know the total distance in the first 3.0 seconds. From a graph of speed time, I can get the velocities, initial and final, and I also know the time is 3.0 seconds. I'm looking for distance d. So my initial velocity from the graph would be 0 meters per second. At 3 seconds, my final velocity would be 8.0 meters per second. To get that distance, I'm going to use average speed is distance over time. So distance is average speed times time. What is the average of 0 and 8? No, I'm not giving you an 8% on a quiz if you got a 0 on one quiz and an 8 on another. What's the average if you got a 0 and an 8? 4. 0 plus 8 is 8 divided by 2. 4.0 meters per second. So I'm going to take 4.0 meters per second and multiply by 3.0 seconds, which 4 times 3 is 12, choice number 1. Anything else through 20? 1? 14. 14 says, what is the total distance traveled by an object that moves with an average speed of 6.0 meters per second for 8.0 seconds? So I'm giving you the V bar, 6.0 meters per second. I'm giving you the T, 8.0 seconds. You're looking for D. Same equation we were using in the last question. V bar is D over T. So D is V bar T. 6.0 meters per second times 8.0 seconds. 6 times 8 is 48, choice 4. Anything else through 20? Miriam? I'm sorry? 19. 19 says that we have a skier who starts from rest, skiing straight down a slope, which is 50 meters long in 5.0 seconds. What's the acceleration? So my VI is 0 meters per second. The D is 50 meters. The T is 5.0 seconds. I'm looking for A. The best equation with those variables is D is VIT plus half AT squared. The VI is 0. That's going to go away. So I'm going to end up with D is half AT squared. To get the A, I multiply the D by 2, and then I divide by the time squared. So 2 times 50 meters divided by 5.0 seconds, which must get squared. That's 100 over 25, which of course is 4.0 meters per second squared, choice 4. Anything else over 20 or through 20? All right, next 2 pages then, which gets us through question 28. Anything through 28? Khalees. Okay, so 21 is talking about this graph of displacement time, and I want to know the total distance traveled in that 10 seconds. So what I can see from the graph is that I started at a position of 0. I went out on a number line. I'm going to just kind of make a number line here. Here is the 0 meter position, and I see the farthest position on the graph is 16 meters. We started off by going to the 16 meter position between 0 and 8 seconds. I'm moving forward from 0 to 16, and then I have to backtrack, and I end up at the 8 meter position. The distance traveled would be the sum of those 2 arrows. I don't care about the direction. So the distance traveled would be 16 meters plus 8 meters, which is 24 meters, choice number 4. Okay, does that make sense? The graph, 16 meters. So between 0 and 8 seconds, I am moving to the right until I reach the 16 meter position. Then at between 8 and 10 seconds, I backtrack and I end up at the 8 meter position on my number line. Okay, so that's how you get the distance.
For number 21, I did like 4, I like counted like each box as like the line that crosses the line. I counted like that.
Well, it's 4, 8, 12, 16, and then another 4, and then another 4. It's the same thing. But you should really just be reading the numbers off the graph. Okay, number 22. We have a motorboat which has a speed of 5.0 meters per second in still water, headed east across a river which flows south at 3.3 meters per second. What is the resultant velocity? So what they're telling you is that the boat is traveling this way at 5.0 meters per second, but the river is going south at 3.3 meters per second. The resulting velocity of the boat is the hypotenuse of that right triangle. So how do you get the hypotenuse? Yep, so if we do that, that's 5 squared plus 3.3 squared. And then take the square root of that, and that gives me an answer of about 6 meters per second, choice 3. Number 23 says a car is traveling 90 meters due north in 15 seconds. Then they turn around and go 40 meters south in 5 seconds. What is the average velocity? Velocity uses displacement. So I need to know the displacement and the time to get the average velocity. I'm going to sketch it out. 90 meters north, and then I'm going to turn around and come 40 meters south. My displacement is that arrow right there, which is 50 meters to the north. The time traveled, 15 plus 5 would be 20 seconds. So to get the average velocity, I take the displacement and divide by time. So 50 meters to the north divided by 20 seconds. 5 divided by 2 would give me 2.5 meters per second to the north for that average velocity. The magnitude of it is just choice 1. Anything else here through question number 28? Miriam? 25 says, and we are referring to this graph here, which is figure 3. What is the acceleration of the car at 6 seconds? So 6 seconds on the graph is right here. And I can see from the graph at 6 seconds that that is my velocity. But to get the acceleration, I talk about slopes on these graphs. Notice that I am on a line. A line has a constant slope, which means the acceleration is the same all the way from point E to point F on the graph. So to get that slope, which would be the change in the velocity over the time, I'm going to take the final velocity, 0 meters per second, and subtract the initial velocity, which is positive 20 meters per second, and divide it by the length of the time for that time interval, which is 2 seconds. So that gives me negative 10 over 2, or negative 5.0 meters per second squared, which is choice number 2. Anything else through 28? All right, next 2 pages then through 36. Anything here through 36 that you'd like to go over? Kira.
29.
Okay, 29. Which vector diagram has the greatest displacement? Displacement is measured from the start to the end position. In the first diagram, if I start here and I end here, that displacement is 1 meter going north. In this diagram, my displacement is that arrow. So if I use Pythag to figure out what that is, 1 squared plus 1 squared, then take the square root of that, that gives me a displacement equal to 1.4 meters. If I do that in diagram 3, from start to end position, that arrow there is my displacement. I can see that that displacement is just 1 meter, but it points west. Now in this diagram, my start and end positions are the same. So the displacement is 0 meters. Which one has the biggest displacement? Choice 2, 1.4 meters. And the other one you asked about was? 31. Which pair of graphs represents the same motion? So let's start with our displacement time graphs and describe what they're saying. This one's a diagonal line, which means I have a constant velocity to the right. I know I'm moving to the right because it has a positive slope. This graph, diagonal line, means I have a constant velocity, but since it's a negative slope, it means I'm going to the left. This one here, horizontal line, means I'm not moving. In other words, my velocity is 0. This graph is the same as graph 1, so this is a constant velocity to the right. Let's now look at the velocity graphs and describe them. This graph shows a constant velocity. Are these matching descriptions? Nope. This graph shows that my velocity is increasing over time to the right. So this one shows me speeding up to the right. Matching descriptions? Nope. Graph 3, this velocity is the same as the one we saw in diagram 2. This is speeding up to the right. Matching descriptions? Nope. Graph 4, this is also speeding up to the right. Do these match? Nope. Wow. Okay, so where do we have, and actually this one is. My mistake. Are these matching descriptions? Constant velocity. This is in the positive quadrant, so it's going to the right. My mistake. Those are matching descriptions. I just didn't finish the description on that. Anxious to get it done, so it is number 1. Okay? Anything else through 36? Sydney? Yep. 35 wants the resultant velocity. All right, so this is the third one now, which is asking us for the resultant velocity. I see in the diagram I have 2 velocities, but they are not head to tail. We're going to put them head to tail. So I'm going to keep the one to the right at 1.50 meters per second, and I move the other one to its head at 0.70 meters per second. So my resulting velocity is the hypotenuse of that right triangle, which points up and right. We use Pythag to do it. So 1.5 squared plus 0.7 squared, then take the square root, and it gives me an answer of about 1.7 meters per second, choice 4. Anything else through 36? Kira? 32. This is a ticker tape diagram. I want to know, it tells me that the oil drips at 0.4 second intervals from a car that has an oil leak. Which pattern best represents the spacing of the oil drops as it accelerates uniformly from rest? That means it's speeding up at a constant rate. Which pattern of dots shows it's speeding up at a constant rate? Choice 2, the dots should be close together and get further and further and further apart uniformly. It's the only one that does that. 1 is a constant speed. 3 is I don't know what. And 4 is I don't know what either. It's jerky motion, back and forth, back and forth, back and forth. So it's not uniform. All right, next 2 pages then through 49. Anything through 49? Miriam? 44. 44 says an egg is dropped from a 3rd-story window. The distance the egg falls from the window to the ground is closest to what? Okay, we had a question in our Unit 4 packet where things were going up certain amounts of stories. And I think I mentioned to you, and I think we put it in our packet, that 1 story from here to the ceiling, if I were to get rid of the drop ceiling and go to the floor above, the floor joists, it would be about 3 meters. Okay. So if I have a 3rd-story window, about how many meters would that be? About 9. Which of these answers is closest to 9? 10 to the 0 power is 1 meter. 10 to the 1 power is 10 meters. 10 to the 2 power is 100 meters. 10 to the 3 power is 1,000 meters. Which one's closest to 9 meters? Yep. So that's a scientific notation problem. Plus, we do expect that you can approximate distances because you've been working with meter sticks. You should know how long a meter stick is. So 1 meter is that 10 to the 0. Obviously, it's more than 1 meter up to the ceiling.
How are you supposed to know like 1 story?
I'm telling you right now.
So we can do that.
Well, yeah. So, but I mean, look at the ceiling. 1 story. About how many meters? If you had to guess with this stick, we asked you to make approximations. This is a meter. How many of these sticks do you think it would take me to get from here to the floor joist above the drop? About 3. Obviously, it's more than 1. 1 is the doorknob. Yeah, exactly 1. Doorknob on a door is always a meter up. So keep that in mind, okay? We expect you to know that distance because you've been working with meter sticks in science labs for a while. Anything else through 49? All right, next 2 pages then through question number 60. Period. 52. We have a car that's moving at a speed of 8.0 meters per second, entering a highway, accelerating at 3.0 meters per second squared. How fast is the car moving after it accelerates for 56 meters? So the VI is 8.0 meters per second. The A is 3.0 meter per second squared. The D is 56 meters. I'm looking for the VF. So VF squared is VI squared plus 2AD, which means that VF is the square root of VI squared plus 2AD. I'm now going to do my substitution with units. So VI is 8.0 meters per second, which should get squared, plus 2 times 3.0 meter per second squared times 56 meters. So let's plug that into the calculator. 8 squared plus 2 times 3 times 56. Then you take your square root, and that gives you 20. Choice number 2. Anything else through question 60? Yes, Kira? Okay, these are referring to figure 3, which was back a few pages. Figure 3 was on this page right here. See, it says figure 3. There's the graph that we're using for these questions. So I'm sorry, you said 54 and 55? 54 wants the average velocity from D to E. All right, so let's look at the graph. This is a graph of velocity and time. So what I can see here at point D, the VI would be positive 20 meters per second. And the VF at point E is also positive 20 meters per second. What is the average of 20 and 20? No. If you got a 20 on one test and a 20 on the next test, what would your average be? 20. Remember how you get an average of two numbers, you add them up and you divide by 2. You have to have that memorized. You should know how to get an average of numbers. Add them up and divide by 2. So that is question number 54, 20 meters per second. Number 55, which car, the car that has the largest displacement during interval, and we're giving you 4 choices. On a graph of velocity time, the displacement would be equal to the area between the line and the time axis. So let's look at the 4 choices. F to G is here. What's the area there? Yeah, so there is no displacement from F to G because our velocity is 0. When you're not moving, you can't be displaced. So that is obviously out. Let's look at B to D. From B to D, I'm looking at all of that area. Okay. From E to F, I'm looking at that area. And from D to E, grab a different color so we can see it. From D to E, I'm looking at that area. Which of those shapes is the biggest? B to D is 2 seconds. D to E is 2 seconds. E to F is 2 seconds. I believe it's D to E. That's the biggest shape. So that means it is choice 4. That gives us the largest area or the biggest shape. Anything else through 60? Khalees? Number 60. This is a graph of speed time, and I want to know which one has the greatest average acceleration in that 6 seconds. So the greatest average acceleration would be found using the change in the velocity over the time, which means that if they're all the same time, I'm really just looking at the direct relationship between the velocity change and the acceleration. So if I look at car A, notice that car A is a horizontal line. So the change in velocity there is 0, which means that has no acceleration. Okay. If I look at car B starts here and it ends here. So that is the velocity change for car B. I'm just going to mark that. That is that velocity change. For car C, it starts here, ends here. I think it ends about here. So there is the velocity change for car C. And then car D starts here, ends here. So the velocity change for car D is that vertical arrow. Which one has the biggest velocity change? D. Therefore, that has the biggest average acceleration. Anything else for 60? Which paragraphs are the same motion? Okay, I'm going to do what I did with the last one, write descriptions. So this distance time graph in number 1 shows that the velocity is 0. You're not moving. This one here, well, let's go to this one. This one shows us slowing down because the graph levels off. This one shows us speeding up because it's getting steeper. And this one shows us traveling with a constant velocity or speed. What is this graph of speed time showing us? This is showing us speeding up. This one shows us traveling with a constant speed. This one shows us speeding up. And this one shows us speeding up. Which one matches? 3. Anything else through 60? All right, next 2 pages. That finishes the packet through question 70. Anything through 70? Kira. All right, 66. Length of a high school physics classroom. Let's just change these to meters, get them out of scientific notation, which your calculator can do for you. This would be 0.01 meter. That's the same thing as 1 centimeter. 10 to the negative 1 meters would be 0.10 meters. That's the same thing as 10 centimeters. 10 to the 1 meters would be 10 meters. 10 to the 4 meters would be 10,000 meters. How many of these do you think you need to go from that wall to that wall? What's the best guess? Of these choices, which is the best guess? Yeah, 10 meters, right? 10,000 meters. That's 10 kilometers. That's like 10 miles. A kilometer is like a mile. Okay. So 10 meters would be the best choice. Choice number 3. Obviously, it's not a centimeter. You're going to have a ruler on your test. Look, right? A centimeter is like that on your ruler. Don't pick that. Okay, now what's the approximate diameter of a dinner plate? Show me with your hands, Kiara, how big a plate is. Okay, so it's less than a meter. Let's look at these. This is more than a meter. That's out. This is the same thing as a quarter of a meter, right? 0.25 is a quarter. This would be the same thing as 2.5 centimeters, and that's 2.5 millimeters. How much of this stick is a dinner plate? About a quarter. Choice 3. Achilles? Yep, 65. A baseball pitcher throws a fastball at 42 meters per second. The batter is 18 meters from the pitcher. How much time does it take? Okay, so we know that the V is 42 meters per second. I'm assuming that's going at a constant speed, so that would be the same thing as the V bar. The D is 18 meters. I'm looking for the time. We're going to use the equation V bar is D over T. So T is D over V bar. That is 18 meters divided by 42 meters per second. When I work that out, 18 divided by 42 is 0.43 seconds, choice 4. Anything else through 70? Ryder? Yep. What's the average speed in figure 5, which is this one here? This is figure 5 during the first 4 seconds. Okay, average speed, we need the secant line so we can find the slope of it. So if I were just to quickly sketch it, there it would be, which means that I can see that the displacement from 0 to 4 seconds is 8 meters. The time is 4.0 seconds. I'm looking for the V bar. We would use V bar is D over T, which is 8 meters over 4 seconds, or 2 meters per second, choice 2. All right, take your break. When you come back, we're going to do our first lab of the second quarter.
I got 4. I was giving Alex a higher. 6 meters, John. Bro, you said how many meters 6 would go like from top step? 6. From 6 foot. The wall, it was a wall.
You might need a pass. Right, a
You still want to know.
Actually, let's just I'll just do it. Yeah, you're welcome. Because I want you to have the full period.
That was so fun. I was you missed red flag. Yes.
I got it wrong. I got 3 questions on it.
No. It's a regular paper lab. So what you need for the lab, you're going to need, I'll write it up on the chalkboard, what you need. You can clear your desk of everything but a reference table, pencil, and calculator. Yeah. I'm sorry, do I remember what? I can't remember. I don't remember. You'll get it back tomorrow. I just answered that tomorrow. No, it's just like a regular test. 10 multiple choice worth 50 points and show work worth 50 points. Folks, go ahead, clear your desk of everything but a reference table, a pencil, and a calculator, please. Everything away except a pencil, reference table, and calculator. Reference table, pencil, and calculator.
Yeah, I swear it was by accident.
Smartest dude I've ever known.
All right, on the top of your lab worksheet, go ahead and put your name. This is lab number 9. You will be working with a partner, and when you get to a partner, I need you to put their name on it. Without their name on the partner line, I will be giving you a 0 for the lab, which is your first lab of the second quarter. Okay, because your lab and your partner's lab are going to get graded together. As you can see in this lab, we will be measuring or calculating rather your reaction time. And here's how we're going to do it. Between you and your partner, you're going to get a meter stick. I'm going to demonstrate what you're going to do. You are going to stand when you do this lab, when you are collecting your data. You'll see you have 2 charts to complete, table 1 and table 2. Table 3 is a summary of the answers of things. All right, I'll show you what you're going to do. When you are measuring your displacements, your partner is going to drop a meter stick and you're going to catch it. But here's how you're going to do it. You're going to use your dominant hand. I'm right-handed, so I would use my right hand, and you're going to put your hand in a claw fashion when you do this. You have to stand with that dominant hand on the desk, with this part of your hand on the desk. So you have this little claw off the end, and I want you to put some pressure on it so it doesn't move. Okay? Because if your hand moves as this is falling, it just messes up your data. It's not good data. What your partner is going to do is they're going to look for where the 0 mark on the meter stick is. This is obviously, it's not good data because my reaction of me dropping it for myself, I know when I'm dropping it. You're not going to tell your partner when you're dropping this. But what you're going to do is you're going to drop it like this. Your partner is going to drop it with the 0 lined up with the top of your fingers, in between your fingers, and you're going to catch it as quick as you can. It's not going to happen that fast. All right? You're going to get something up in this range, I hope. Not up here. If it fell that far, let me know when you get your driver's license because I will make sure I am as far away from you as possible because you have a bad reaction time. And what you're going to do is record how far it fell to the nearest tenth of a centimeter. So you're going to record to the nearest tenth of a centimeter. You're going to do that in both charts. Now, your chart and your partner's charts are going to be flipped, right? Your displacements will go on your partner's lab in the partner's column and vice versa. Notice how many times you're going to do that. 10 times for each of you. And then when you're done, you're going to get an average. And remember that the averages are going to go to the 10th of a centimeter. They have to keep the same precision as the data itself. Once you have those numbers, you are then going to complete the results table. Notice that in table 3, the displacements are not in centimeters anymore. Now they're in meters. To go from an average in centimeters to a displacement in meters, you're going to move the decimal point 2 times to the left. So let me give you an example. I'm just going to do an example so you understand what I mean. If this average, well, let's say it was 19.6. I'm going to move the decimal 2 places left. So for me, that would be 0.196. Don't write that down. That's not your numbers. That's just a made up number I have. Do you understand what you have to do, though, to go from here to here? Yes or no? Okay. So now let's talk about what the acceleration is of that meter stick. What's the acceleration of the meter stick after you let it go? Hold on a second. Oh. Yes, can I read it? Okay. Okay, you're welcome. Claudia, you gotta head to Lucy's office. Bring your backpack with you. Okay, so what we're going to do now, you just told me what the acceleration is. 9.81 meter per second squared. We don't have to write the units. It's already in the column previous. So we just put the number. And then the rest of this you are going to fill out by using the data here. These are your givens. Question 1, I think you're going to answer this in a sentence. And then anytime it says calculate, you got to use guess method. Okay, use your guess method. Then in number 6, these are complete sentences. Okay, make sure you answer number 6 in complete sentences. Your answers to questions 1 through 5 help you populate this data table. And then your lab is done. When I say use the guess method, you do not need to do the checks. No checks are needed. Just givens unknown, equation, algebraic manipulation, substitution with units, final answer with units and sig figs. Okay? If you're missing any of those things, you're going to lose full credit for the question. There'll be no half points given on this lab. It's either right or it's wrong. And you're working with your partner on the whole thing. So notice that I am telling you what your unknown is in each of these questions. You're just doing one for you and one for your partner. And then you can, right? You can each do your own and then check each other. Make sure, work together to answer this. This is due by the end of the period. When it is done, I'd like you to put it in the blue bin up there. Okay? Questions? You're going to work with the person that you're sitting with. Since Flavia just left, Emma and Max, you guys are going to work together as partners. Okay, so right now, get your partner's name on the partner line, person who's sitting with you. First name is fine. I'll give each of you 1 meter stick. You're going to work at your desk. Once you have all 20 displacements recorded, let me know. You can then bring your meter stick back up to me. Okay, no questions? This is your first lab for the second quarter. Give everybody a gator stick. Get up out of your seat. Stand. So you can stand up while you're collecting.
Yo.
I literally caught it, bro. It didn't hit my hand. Catch it?
No, bro.
I literally caught it, bro. Okay, it literally hit my hand. And it's like,
So, what we supposed to go here? Yes.
Go to the 10th of a centimeter. 10th of a centimeter.
Are you making the measurement at the top?